Logarithmic parent function is f of x equals to log of x. Log of x graph has an x-intercept at, why are we still talking? I think that might be too far, but it should have a y-intercept at, x-intercept at 1. Okay. There, it's better. Okay. And it's always the inverse function to an exponential function of 10, base 10 to the x power. Okay. So whatever base it is, it's going to be exponential. Is it growth or decay? Both? No, you cannot have both. It's either or. That cookie's getting to your head. So let's try that again. If I have a base 10, is it a growth or a decay? It should be a growth. Okay? So whatever this exponential graph is, it's going to be the inverse of it. Do you guys remember how we switched the ordered pairs? Okay? So if this one is 0, 1, then what's this one's x-intercept? 1, 0. The numbers switch places, right? X and Y. I have all the computers closed. This is a legit lesson. It's not something we're making up. It's not something we're reviewing. It's new. Okay? All right. Because you can graph base 10 logs on your calculator, you will need to use the inverse exponential function, then invert the values from the table to the graph for the logarithmic function. So you have to make 2 tables every time. Okay? You have to make 2 tables every time. One is going to be the exponential function first. Okay? Exponential function. And then you're going to change it to the log function by inverting the x and y from the exponential. Okay? So exponential function. What are the numbers that I asked you to pick? Matthew, screen's this way. Exponential, where's your packet? Okay, you're writing, because that's not the right page, is it? It is? Awesome. Okay. What are the numbers that I asked you to pick? -2, -1, 0, 1, and 2. Okay? Exponential function would be y equals, what's the base? 2, right? This is 2. Okay. To some function, I don't know what that is. I'm going to put that as x. This is y. Does that make sense? Remember the inverse? Do you want me to write it again? Sorry, that might be confusing. We have to change to the inverse function. So the inverse function will be f to the negative first power of x equals 2, where log base 2 is now of y. That's supposed to equal x. Now we solve for y. Do you guys remember now? Yes? Okay, so you would rewrite it as 2 to the x power equals to y. Does that make sense? That's why we have to learn how to convert logs to exponentials first. Okay? So this now becomes my exponential function that I'm using to graph, or make the table for, rather. Okay? So let's plug it in. 2 to the negative second power is 2 to the negative, let me do the work in the middle. F to the negative first x. Okay? So that way you guys have it. 2 to the negative second power is 1/4, or 0.25. Okay. 2 to the negative first power, 1/2, or 0.5. 2 to the 0 power. I'm sorry, what?
1.
Oh, good. I thought you said 0. 1. Good. And then 2 to the first power, is 2. You guys doing okay? Okay, anybody not following what I'm doing? I'm just placing the x values into the x position for the exponential function right here. That's where I'm putting my x value. Okay, let me see. Right there, I'm putting these x values in. Okay, so it would be 2 as the base. To the second power is 4. 2 times 2 is 4. Now we invert it. Okay, all the y values that we have here are now going to be in the x value column of your log. Okay, so this would be 0.25, and then the x value is now my y, 0.5, negative 1, 0, sorry, 1, my bad, 1, comma 0, 2, comma 1, and 4, comma 2. Which one are we graphing? The exponential or the log? What was given to us? The log was given to us, so we're going to graph the log. This is the one that you graph, okay? So 0.25 would be negative 2. 0.5 would be negative 1. 1, 0. 2, 1. 4, 2. Okay. Now where's the asymptote? Where's the asymptote? It used to be y equals 0, right? Now it's x equals 0, which is right here. Okay. What's the x-intercept? This is the x-intercept. So it's 1, 0. Okay. What's the domain? Which one has the restriction now? The x's have the restriction. Where does it begin? Begins at 0 and it goes to positive infinity direction, okay? Now, is there a bracket or a parentheses on 0? A lot of people make that mistake. It's not bracket anymore for these functions because we do not hit x equals 0. Is there any values here that's going to hit 0 at x? So it's going towards the 0, but it is not going to hit 0. So it should be 0 to infinity, and then range should be least to greatest. I still have people who are changing those to positive infinity to negative infinity. Please don't do that. It's least to greatest every time. Okay? Least to greatest every time. All right. You ready? Any questions? Again, you do not have to do the end behavior. You do not have to do the as x is approaching 0, what's y doing, all that stuff. You don't have to do those, okay? So you're going to see it in your answer key, but it's not necessary. Okay? But these 2 tables, yes, you have to have 2 tables. Okay? How are we doing? Okay? What's going on? Okay. All right. So if the given function is log base 1/3 of x, what's my inverse function of that? Okay, so switch x and y. Solve for y. What's the base? 1/3. So we're going to write 1/3 to the x power equals to y. So is this a growth or decay? It should be a decay for the exponential function. This is my inverse. The exponential function, okay? So if I do that, here's my x, here's my y. What x value should I pick? Same ones. Negative negative 1, 0, 1, and 2. I'm going to show my work in the center. Okay. It's going to be 1/3 to some power. And then it'll be 1/3 to some power, whatever x is. Sorry, I'm going to put parentheses instead. You decide what those parentheses should hold, okay? If you want to get calculators to help you out, go for it. Do you need the pathway to pressing the buttons? Do you want me to give you the pathway to pressing the buttons? Yes or no? You guys got it? Nobody's giving me a head nod or a shake. Do you need me to write out the pathway for you to put this into a calculator? Okay. On your calculator, here we go. I want you to put parentheses. 1 divide by 3. Close the parentheses. Then you're going to use the up button or the caret button to put negative 2. And then pro tip. What's the pro tip here? So you don't have to keep writing the same thing over and over again. Second function, enter, gives you the last entry you pressed in. Okay, so that should be That should be 9. Am I right? Okay. Y value should be 9. Y value should be 3. Y value should be 1. Y value should be 1/3. Y value should be 1/9, which is 0.3 repeated, and the last one should be 0.1 repeated. See if you get those values. Okay. Okay, thank you. And then you invert them. Okay, here's the actual table we should use. This is the f of x of log base 1/3 of x being graphed with these x and y values. We're gonna place the y values all the way down. I think it helps that we just go down the column rather than going across each time, because it gets kind of confusing. And I have a feeling you're gonna make a mistake if you do x, y, x, y, x, y, and then make a mistake. Y values, I'm gonna put all the x values right in place. Okay, and then you're gonna graph 9, -2. 3, -1. Okay. 1, 0. 0.31. Okay. And then 0.192. Okay, so it should look like this. Okay, where's my asymptote? Where's my asymptote? X equals 0. It's not y equals anymore, it's x equals. X equals 0. Oh man, Miss Bian. Haha, nobody corrected it. Sorry, I fixed it before you said it. All right. Nah, I said it before you did. You just repeated what I said. All right. X-intercept is at 1, 0. What's the domain? Do we start from -infinity or 0? 0, and we're going to go to +infinity. What's the range? Good. Negative infinity to positive infinity. We don't look at left to right. We look from bottom to up for range. Okay? Are we that close? Is that why? Just climbing up, up and up. Okay, step 1. We need to change the given function to its inverse function. In this case, it's the exponential form of it, right? Okay. Step 2. What do we do with that function? Make a table using that exponential function. And then what do we do with that? Make a new table with inverted x and y values. Okay. And then last step would be graph the new table. Okay? Are we clear on the steps? I'm just kind of recapping what we did in a haste after Monday. Okay? So instead of writing y equals log base 4 of x minus 1, what are we going to write? X equals log base 4 of y minus 1. Okay. Now I need to solve for x or y. It's already said equal to x. We don't need it equal to x. We need it equal to y. Okay. So this has a value, b value, and the x value right here. So we can just rearrange it to write it into our exponential form. I hope you guys got tons of practice with it. What's the base here? 4. So I'm going to put 4 to the, is it x power or y minus 1 power? X power. That's going to equal your argument, which is the y minus 1. Okay? Now what do I do to get y by itself? Add 1 to both sides. Yeah, I'll do this one. Add 1, add 1. Can I add 1 to the 4? Why not? Because it has 4 to the x power, and we don't know what power that is, and we can't be changing the base. Okay? So keep it separate. So I'm going to rearrange it where it's y on the left equals to 4 to the x power plus 1. This is my new inverse function that I'm going to use for my table. Okay? This is the part where you have to plug in your x values and get the y out so you can swap the x and y for the new log table. Okay? So, let's see. Should I use blue? Blue sounds good. I'm going to make a wide one where x and y is on the ends. And then the work for 4 to the x power plus 1 is going to go in the middle. Okay. What values should I choose for x? Any questions so far? No? Okay. 4, then add 1, 4, then add 1, 4, then add 1, 4, then add 1, 4, then add 1. So I'm leaving that exponential spot open so I could place those exponents in there. Okay. Is this okay? 4 to the negative second power means what do I do with the base? It's 4 over 1. So you flip it, reciprocal of 4 over 1 is 1/4. 1/4 times 1/4 is 1/16. 1/16 plus 1 will be 1 and 1/16, 17 over 16. What do you get when you get 17 over 16 on your calculator? 70 divided by 16. 1.625?
Yeah.
Cool. Is that 0.625? Oh, okay. 0.625. All right. 4 to the negative first power. What happens to the base? Reciprocal, 1/4. Do I need to multiply that by anything else? Nope. So 1 and 1/4 is 5/4, which is 1.25. Okay. 4 to the 0 power. What's up? Oh, yeah. I just want you to track the work so that way when you're putting it into your calculator, you're not making any mistakes somewhere. Like dropping a negative somewhere might be a problem, or changing the negative to a minus sign might be a problem. So if you want to track those things, it's easier if you write it out. But it is not required. It's not required for you to show me all this work. But if I show the work, you're kind of getting you're setting yourself up to succeed by setting up the work on your paper. Okay? So 4 to the 0 power is 1. 1 plus 1 is so hard. 4 to the first power is 4 plus 1 is 5. There you go. 4 to the second power is 16 plus 1 is 17. Okay. So what do I do with these values? Step 3. Nope. Don't graph it. Flip it. X and Y. Here's a log. So it'd be 1.0625 for negative 2. And then 1.25 for negative 1. 2 for 0. 5 for 1. And 17 for 2. Okay, those are the points you want to graph. Do not graph this one. You graph that one because it's for log, not for the exponential. Okay. Negative 1.0625 will be really, really close to it. To like 0.1, right? And then 1.25, negative 1. A quarter of the way in, and then 2, 0. And then 5, 1. 2, 4, 5, 1. I'm not going to graph 17, 2, but should I pass the 2 line when I graph this? 17 is probably almost double the distance here, right? So should I pass 2 as I'm graphing this? To the edge of the grid, you should not be passing 2. Do you understand why? Okay, I'll explain why. I'm not passing 2 because it's supposed to be 17, 2, right? So if I get to 10, I shouldn't be hitting 2. I should be hitting 17, then at 2. So you should be under 2 when you're graphing this to the edge of the grid. Does that make sense? If you pass 2, I know you didn't really think that through. That would be like graphs for 9.5 rather than 10. I know you guys care, so I'm telling you a heads up. Okay? Where's my asymptote? Y equals 1 or x equals 1? Beautiful. X equals 1. X-intercept is at 2, 0. Ordered pairs, please, always. Domain? Is it all real numbers for domain? So it should be starting at 1 to positive infinity. Does it include 1? Then what do I use as a bracket or parentheses? Parentheses. Okay? It's bracket if you hit 1. If you have a point on x equals 1, then you would use a bracket on 1. Okay? Range. This is how you jump down to an 8.5 from a 10. Yes, I'm getting really tired of this, so I'm hitting you hard on that. If you change the order of it, you should not be changing the order at this point, okay? You should be using negative here and then going to positive. Least to greatest, okay? It's going to hit you hard if you don't get this right. For domain and range, that's a separate learning target. You know that, right? 6.2, I can state the domain and range of the exponential and log functions. If you miss that part, if you miss this part, it's going to be dipping down to 8.5. I want to write a 10 for every one of those. 6.2 should be all 10s at this point. Everyone's gotten 6 months of practice on domain and range. Right? Yes? All right, okay. Here we go. So let's take a look at this. Let's compare. Number 3 and 4, log base 4 of x minus 1. What's the difference with that? And number 4 is log base 3 of x minus 2. I'm talking about the x value. The x relationship with this part and this part. What's the difference? Really obvious. In parentheses. Second one is not in parentheses. Do you think that might mean something? What do you think this is saying?
That means that it's like the power of
It's affecting the x values, right? By going to the right one. What went to the right one in our graph? The asymptote. It shifted to the right one, right? It was at x equals 0 for the whole thing, and then now it's suddenly to the right one. What about this one? What do you think that's going to change? That was the h change because it was the x minus h part, right? Then what's this one changing? The up, down, the k. The y value gets changed in this one because it's not part of the x, it's the whole log being taken away by 2. So you're going down by 2. Does that make sense? Okay, so where's the asymptote going to be for number 4? No, 0. Asymptote is still on 0. The only thing that's happening is that my log is now going to be shifted down 2. Does that make sense? Okay, all right. So we already know the anticipated result of it, so let's go ahead and find our inverse. We're going to start with x equals log base 3 of y minus 2. And I'm solving for y. Solve for y. Okay? So I'm going to add 2 to both sides. It's x plus 2 now, equals to log base 3 of y. How do I get y by itself? What is it? Rewrite it into exponential form. Then you'll get y by itself on one side. Right? So it'd be 3 to the what power? X plus 2. So the whole x plus 2 becomes the exponential part of my power. So 3 is going to stay on the bottom. The exponent is going to be x plus 2. What is that going to equal to? There you go. Okay. When you get to a point where you have just one log with a base and an answer, an argument here, then you can rewrite this whole thing into exponential form. Okay. So do you want me to write it in here that we wrote it into exponential form? Rewrite into exponential form. take this whole thing. Okay. So my table's going to look like, don't use the highlighter. Okay. X and Y. Work is in the middle. Okay. X is going to be -2, -1, 0, 1, and 2. I think I made the heading a little too big. That's so teeny tiny. All right, I'll do what I can. Okay, -2, so 3 to the -2nd power plus 2. 3 to the -2nd power plus 2 gives me 3 to the 0 power, so y equals to 1. 3 to the -1st power plus 2 is 3 to the 1st, which is 3. And then, again, 3 to the 0 power plus 2 makes it 3 to the 2nd power, which is, thank God nobody said 6. Yeah, no idea. Okay. 3 to the, what was that? No, I saw people who write like 2 times 3 is 5.
No, she wrote like 9 times 3.
No, I made tons of mistakes in the last period. I think I'm gonna have to delete the entire video because I made so many mistakes. All right, so 1 plus 2. 3 to the 3rd power is 27. 3 to the 2nd power plus 2 makes it 3 to the 4th power, which is 81. Okay.
27 to the power of 3 like in like 1,000.
Are we good? I don't want to rescale. I know where the asymptote's going to be. I know what my graph curve is going to look like. I don't think we need to rescale. You don't have to rescale. So I'm going to rewrite this into a table for log x and y. What are my x values? 1, 3, 9, 27, and 81. My y values are -2, -1, 0, 1, and 2, respectively. Okay, so 1, -2. 3, -1. 9, 0. It looks like we're leaning towards what value on the left? It looks like we're going down to the 0, right? Because if our asymptote is right on 1, then we wouldn't have 1 as the x value. Does that make sense? Okay, so it's 0. So asymptote, graph it in. Is it dashed line or solid line for asymptotes? Dashed, please. X equals 0. My x-intercept is at 9, 0. What else? Anything else we need to mention? Domain, range. Domain. Uh-huh. Zero to positive infinity. What's the range? Negative infinity to positive infinity, said Megan. Yes. For domain, right? For exponential functions, yes, it could be in the range.
Oh my god, this was so cute.
Asymptote doesn't change because it's not parentheses, right?
Correct. Correct. So,
What are you saying? Where do you get the G from?
do you see how this one, the asymptote changed because the x is being directly affected? And which of the axes is affected by the asymptote? Here, where's the asymptote going to stand by? X. So if you change on the x value, the asymptote is going to change with that x value, okay? If we're changing it in our exponentials, do you guys remember? Oh, come on, you just took a quiz on it. For exponentials, if not the x, but rather the k value changes, then this changed. The asymptote location changed. Okay? So the y value changed. So let's go back to where we were. But if we have k changes on this one, like this one, what changed? The whole log graph it still went down, right? If I go up 2, wouldn't that be where the parent graph's log x-intercept is? Right, 1, 0. So if I go down 2, that's where we landed. Okay? Questions? Doing okay? All right, then let's guess on this, okay? Is my asymptote going to change? Yes. Where's it going to be at? Negative 9. X is being added by 9. Adding by 9 for H means it goes in the opposite direction, remember? So there should be an asymptote on negative 9. Am I moving this up or down? Up. So we should be at 1, 4 probably. Okay? For that x-intercept that used to be at 1, 0 is not going to be at 1, 4. Okay? It's going to shift up. So let's see if it works. Here we go. We're going to change the y to an x. We're going to change the x to a y. Plus 9. Then add 4. So if I want to solve for y, I have to take everything off of it as much as I can until I get to just the log of it. So what do I need to move? Subtract that 4. Then I have x minus 4 equals to log base half of y plus 9. Okay. Now I'm going to rewrite it as half as the base. My exponent is going to be x minus 4. And then I'm going to make it equal to y plus 9. So what do I do now? Is the y by itself? Not yet. So we got to move the 9 over. So we should have y equals half to the x minus 4 power. So I'm going to put this in parentheses down here. So I know that x minus 4 is the exponent minus 9. Okay. I'll make my table for this function, the exponential function, and then we'll invert it for the log. X, then y, negative 2, negative 1, 0, 1, and 2. My work is going to be half to the x minus 4 power minus 9. So whatever my x is, I'm going to take away 4 from it and then raise it from half base to that power. Then subtract by 9. So there's a lot of things to do. Okay? On your calculator, you could put it in as one single entry, but mind you, if you did it wrong the first time and you keep using the wrong one, you're going to end up with the wrong graph. So make sure you are doing this correctly, okay? So I'm going to raise half to some power minus 4, then subtract 9. So that some power is negative 2, so that should be negative 6. Half to the negative 6 power is flipping that half to a 2 over 1. 2 to the 6 power is 2 to the 6 power is
64.
thank you. Because 2 to the 3rd power is 8. 2 sets of those make 64, yes? 8 times 8?
Yeah.
Okay. 64 minus 9. Yeah, I got that too. 55. And then half to negative 1st power, then subtract 4 would be half to the negative 5th power. Flip the half, I get 2. 2 to the 5th is 32. 32 minus 9 is... Okay? We doing okay? Am I going too fast? I don't know. I feel like I'm talking out loud the steps faster than you can put it into your calculator. Do you want me to slow it down? You guys okay? All right, 0 minus 4 would be negative 4. Flip it. 2 to the 4th power is 16. 16 minus 9 is? 16 minus 9. 7. I thought you guys could do it in your head. That's why I just kept on insisting, but okay. 1 minus 4. Negative 3. Flip it. We get 2 to the 3rd power, which is 8. 8 minus 9 is? Negative 1. Yay. Okay.
Wait, Miss Beyond.
Even though I didn't think you needed it, but, you know, Miss Fancy convinced me otherwise.
Wait, Miss Beyond. Can you give us like a challenge for the test so we can start it?
I don't know, maybe.
Yeah, it's like no.
I used to do that last year.
Are we gonna have calculators?
Yeah, you're gonna have a calculator for 2/3 of the test. 1/3 of the test without.
Wait, so what happens to that 1/3?
1/3 is 2 of the 10 learning targets. Well, I guess it's
I know, but why would you?
1/5, so
why would you-
20%.
Why would you take it for like?
Because you don't need it, and I want to know if you know the properties of log. Yeah.
Yeah, so that's why we should do like
You don't know? Then you should probably rely on this yellow paper. Lovely yellow paper that has all the properties that you can write, and include anything else that you'd like to add. You can add it, okay? What's up?
Like compression.
What about compression?
Is it compressing it together? Is that what you're talking about? It's about
Like changing it to single log or expanding it? Yes. That's why you don't need the calculator. Because calculator would actually hinder you from doing it rather than helping you. All right, so negative 2nd power, half to the negative 2nd power is 2 to the 2 power 4 minus 9, making it negative 5. Yeah? Okay, swap those numbers, invert those numbers for the log. So I have 55. Not graphing that. 23. Not graphing that. 7. I'm graphing that one. Negative 1 and negative 5. And then I have negative 2, negative 1, 0, negative 1, 2. There you go. Okay? We're doing okay. Maybe I was wrong. Where's the asymptote supposed to be?
9. Negative 9.
Negative 9. Okay, let's see if it happens. Okay? Negative 55 will be way on this side somewhere in this world of the grid, right? Negative 2. So I'm not going to graph that. Negative 23, 23, negative 1 is going to be somewhere here. No, even less than that in comparison to that one, okay? So I'm not going to graph those. 7, 0, I can graph that one, so I'll graph that one. And then it should slowly be moving upward as we approach negative infinity for x, okay? So negative 1, 1. Negative 5, 2, 3, 4, 5. Negative 5, 2. And we already know this is where my asymptote is supposed to be. If you don't, what should we do to figure out how close we get? Put it into your calculator, right? Put it into your calculator, -6. For x, -5. For x, -8 for x. And see what happens, okay? All right, here we go. So it looks like we're gonna be climbing. 아이고. Let's try again. Okay? So, this is what the graph is supposed to look like. Okay? So the asymptote lies at x equals -9. X-intercept is at 7, 0. Don't just write 7. 7, 0 is what I'm looking for. Domain? -9 to positive infinity. What's my range? Yep. And then what? That's it.